So you've been prompting the AI for hours, building your dream application. Everything is looking great. You decide you'll make just one more change. As soon as you submit your prompt, Claude goes rogue and completely breaks everything. All of a sudden, you've lost hours of work and are pathetically pleading with the AI to go back in time. In this video, I'm going to teach you how to prevent this from ever happening again. I'm going to explain the basics of Git and GitHub, two indispensable version control tools for software development. I'll show you how to prompt Cursor to save early and save often. By the end of the video, you'll be well on your way to never losing your work again. Welcome back to Tommy Codes. Let's get into the video. Before we talk about version control in software development, I want us to look at version control in an area that you might be more familiar with. And here I've got a Google Drive folder and it's called Super Important Project. And it consists of a document called Important Doc. So we can see here I've got V1 of the doc, it just says hey, and then V2 says, hey there, I'm excited to work on this. If you've ever gone to school and you've worked on papers, you might have done something like this before. If you have to work on something for a long time and if you're getting a bunch of revisions that you have to address, it's helpful to save your document at different points in time and assign them versions. So you can see in this case, I've got V1 and V2. And maybe this was a draft of a paper for a class and you got some feedback from your teacher and now it's time to write V3. So what do? You go in and you create a new Google Doc. You go in here, you name it Important Doc V3, and you write your new document. So this right here is version control. This is the same exact problem that we have in software development. The difference is in software development, we have a lot more files to deal with and a lot more versions. Let's take a look at this app I built using Cursor. It's just a simple little tic-tac-toe game. But what is the app itself? How could I share the app with somebody? If somebody said, hey, send me the code, what would that actually mean? So in the case of the Word document, the entire project was contained in a single file. But in this case, our software project is going to consist of hundreds or maybe even thousands of different files. If we take a look here, not only do we have files, we have a folder structure and a lot of different stuff going on. So if I wanted to send somebody this project, what that means is I would have to send them every single one of these files, and they would have to unpack them in a folder on their computer in the exact same order, in the exact same place. So instead of just having to version a single file, we actually have to version every single file within the repository. When you're thinking about a change, which we'll get into later, that could span multiple files. So it gets a lot more complicated. And just to illustrate again that we're talking about a lot of different files, this is the Finder view of that same app. And if you click around here, this might be a more familiar view for you. We can see that it gets quite deep. We have several layers deep of nesting. And mind you, this is a very straightforward project. I built this in one prompt. So you can imagine as your project gets more and more complex, this just becomes more and more of a pain in the ass to deal with. And as you might be thinking, if every time you had to share a project with somebody, you had to go and take all of the files in the folder, upload them to Google Drive, or just send them over an email in a zip file or something, and then have the other person unzip everything and put it in the right place, you could imagine how it'd be almost impossible to collaborate. If you've been vibe coding a decent amount, you've probably heard of GitHub by now. It's a website where you can upload different coding projects and share them with a lot of different people. It's very easy to sign up. You just create an account. Once you do, you can start uploading code immediately. And all of the major text to web app prompting tools like Lovable are gonna have built-in integrations with GitHub that make it pretty straightforward to take your project off of Lovable and into GitHub. You're definitely gonna wanna do that if you wanna share with anybody or if you're gonna pull it into a tool like Cursor to make more changes to your app. And if we look here, we're gonna see the entire project and we're gonna see all of the same files and folders that we saw in both Finder and Cursor. So if we go over here, we're gonna see VS Code, app, favicon, blah, blah, blah. We go here, we see VS Code, app, and then if you click on one of the folders, you'll actually get the full file tree on the left-hand side, and that's where we're gonna see this favicon. And then if we go back into Finder, again, this is just to illustrate, this is all the same view. We're gonna see the same file tree here. So GitHub is the place where all these projects are stored, but Git, G-I-T, is the program, is the backbone that makes all of this possible. Git is actually a free program. Anyone can run it. It runs locally on your computer. It also runs in the servers. And Git is what we're really going to be talking about today. GitHub is just a website that hosts the repositories and makes it easy to share. So GitHub could kind of be thought of like Google Drive. But Git is far more sophisticated. So when you hear people talking about Git and GitHub, they are different things. GitHub is a specific website that you can host Git repositories on, but the whole technology that manages all of the versions, that's just Git, G-I-T, Git. And software developers use Git pretty much every single day. And if you're vibe coding, you basically have to use it every single day as well. So this is GitHub, but I also mentioned that Git tracks the versions of your project. And we were in the Google Docs example, I was talking about how you had to manually append the version numbers. So we had V1, we have V2, and all of that. Well, Git and GitHub, they automatically track the version numbers. And if we look here, we can actually see the latest change or the latest commit. In Git, a change set is called a commit. So you would say, I made a commit to add tic-tac-toe to my app. I made a commit to fix the padding on the button. I made a commit to fix that bug with the login. Every commit is going to consist of a few different things. First of all, it's going to have an author. So that's why you see me and my profile there. Then it's going to have a timestamp. So you're going to see when it happened. It's also going to have a message. So we're going to see here that this commit reverted some calculator that I was trying to add. The message is written by the author of the commit, and it can be literally anything. Generally, you want this to be something descriptive, so you would explain what change you were making and crucially why you made the change. But often you'll find in a lot of software projects, these commit messages are complete dog shit. Then you're finally going to see the version number up here. It's this scary looking thing. It's called a hash. So you would say this is the commit hash. And in this case, the hash is 7933D46. And actually, the hash is much longer than this. They're just showing you a shortened version of it. This is completely randomly generated. You don't have to manage this. But if we were to refer to this version of the code, the most explicit way to refer to this version would be to say version 7933D46. And as you could guess, you generally will not be referring to code using these tags because they're just quite a mouthful and they're not really designed for English. There's also a branch associated with this commit. We are not going to get into branches today. That's probably going to be for a future video. But branches enable you to have people doing different strands of work on the same repository, and they allow you to combine things without causing a bunch of collisions. If you think about Google Docs, if you had multiple different people editing this doc at the same time, it could start to get really hairy. And on a bigger software project, you might not just have 2 people, you might have 100 people working on the same Google Doc at the same time. So branches are going to help you do that, but we're not going to worry about that because it's a little bit more of an advanced concept. So that's a lot of what is associated with the commit. But then if we look at the contents of the commit, that's going to pull up a file tree. And then also this is called the diff view. So if I was reading this commit, I would look and I would say, okay, the 2 files that changed in my repository were app/page.tsx and then also components/calculator.tsx. And if we look at page.tsx, we can see that on line 5, we removed this line here. And then we also removed this section between line 34 and line 37. If we look at the calculator.tsx, it's all in red. So that means that we literally removed all of this. So this file was deleted in this commit. You'll also notice that commits have parents, and that allows us to track what happened before. So if we look at the previous commit, or the thing that happened before I did this revert, you'll notice that this is when I actually added the calculator. And if we look here in the page.tsx, we're actually going to see some green, because in this change, I added that code. And then in the calculator, this file was created, so the entire thing is green. You don't necessarily need to be going through commits like this, but it's important to understand what they are, and also the type of versioning that you get. In a Google Doc, I think Google might have some sort of diff view where they can show you what was added, but it's definitely not as sophisticated as a full code repository. And I would honestly bet that they're using a technology like Git under the hood. So I've got cursor open here, and we're going to take a look at the file tree for just 1 second. And if you'll notice, I got this folder app, which we remember from Finder and also GitHub. But if we look down, we have this subfolder called tic-tac-toe, and it's got this file called page.tsx. If we actually go back over into GitHub, and then we click on the main page of the repository, and we go under app, you're going to notice that there is no tic-tac-toe folder. And the reason that's not there yet is I haven't pushed my changes up to GitHub. So with Git, version control is decentralized. What that means is it's not like a Google Doc. If you go in your cursor and you start like typing random stuff in this file, that is not going to automatically appear on GitHub. That is not going to automatically appear for everyone else. If we were all in a Google Doc and we were just typing stuff in, we would all see it live. So you have to explicitly push up your changes to the repository. And likewise, you also have to explicitly pull down the changes from other people from the repository. How do I know what changes I've actually made so far? So first, we are going to open up a terminal, and the terminal is where you're going to run commands. I know it can be a little scary, but I just want to illustrate a little bit about what's going on. And Git is what's called a command line program. So you're going to run it by typing in git git. And the command that we really want to care about, that one of the most important commands you're going to have, is called git status. If you do a git status, you'll notice here that I have a bunch of stuff in red. You don't need to worry about all the output. You don't need to worry about staging, all of that stuff. But notice how it says modified, app/page.tsx, and then we have this thing that's called untracked. So if we look in page.tsx, and notice in the gutter over here from lines 24 to 26, it has this little green here. This is cursor trying to tell us, hey, you actually modified lines 24 to 26, and you haven't saved it yet. And this actually makes sense because I'm adding the link to the tic-tac-toe page on my app. So that's why this is in yellow, and that's why we see it in modified. And then tic-tac-toe app page.tsx, this is a brand new file, and that's why it's under untracked. And that's why everything is in green. But Cursor is trying to help you understand what changes you don't have saved yet. And the fact that we see any output from git status tells me that we need to actually go and save these changes. So I'm gonna have Cursor make a commit for us, and I'm also gonna explicitly tell it to write a commit message so that later, a few months down the line, I can remember what change was actually made. So let's go ahead and do that. Okay, so I told it to make a commit for me and write a concise message. We're watching that happen live. This is a very straightforward task. I really don't expect any issues. It is going to run a command because Git is a command line program. So anytime you're dealing with Git or you're having Cursor help you, it really is just gonna be running these commands, and that's why I wanna show you the command line, even if you're a little scared of it. Okay, cool, so went ahead and did that. And now let's look at some of the differences in Cursor. First of all, the coloring is completely gone. If we go back into page.tsx, you notice that that green line in the gutter is now gone. And if we run a git status, we will see this output which says, nothing to commit, working tree clean. That means that everything is saved. So that's like in a video game, you went and clicked saved. In Google Docs, you actually saved your project. Like this is the state you generally want to be in. All right, let's do a refresh on GitHub. And if we look on the left-hand side, I still don't see tic-tac-toe. Weird. Well, not weird. I knew this was going to happen. But I want to illustrate a main point, which is that we committed that change, but that still didn't apply the change to GitHub. That change only occurred locally. So a commit is an operation that does not even require internet. That's going to happen completely locally. Now we want to actually push those changes up to GitHub. Now you are going to need to configure Git and GitHub for this to work. So in Cursor, you can go and you can type in GitHub up here. You can log in. You're going to want to do that, and you're actually going to need to do that for the push to work because this is going to require authentication with your GitHub account. So now we're going to have Cursor push the changes, or rather upload all the files back to GitHub. So we're going to say push. So I told it to push the changes to GitHub. Cool, so went ahead and did that. Now let's go into GitHub. Let's refresh. And boom, now we actually have the tic-tac-toe and everything is synced up. So what we just figured out here is that there's kind of two different layers to saving your project. There is making a commit, which is crystallizing the set of changes you made into that commit object. And the reason you want to do that is once you make a commit, you can always go back and forth between commits and everything is going to be exactly the same. You don't have to worry about losing your work if you have a commit. Even if you don't know what you're doing and even if you get confused, if you at least have the commits, somebody could come and help you and they actually would be able to help you. If you don't have commits, if you didn't save your work, there's like literally nothing they can do. However, that is not all of the saving you want to do because just making a commit will not save your work on GitHub. And you can think of it like if you broke your laptop, like if you dropped your laptop in a lake or something and it stopped working, but you committed your changes and did not push them to GitHub, then they are just gone because they only existed on your laptop. However, if you committed the changes, then pushed them to GitHub, and then dropped your laptop in a lake, you would obviously have to buy a new laptop, but you could at least pull down your code and pick up exactly where you left off. So the general rule is going to be to commit early and commit often. And when I'm working with Cursor, I like to commit after every single time I have it implement a full feature, and especially before I have it do something that I'm not sure it's going to be able to do. So what do I mean by that? Let's go to tic-tac-toe. Let's see if we can get it to do something a little crazy. So we have tic-tac-toe here. Why don't we have it add Minesweeper now? I don't know if it's going to be able to do Minesweeper. That seems a little more complicated. So let's start a new chat and let's say, okay, so I'm telling it to add Minesweeper to the tic-tac-toe page. This is honestly a ridiculous request, and I have no idea if it's going to be able to do it. I'm kind of expecting it to create a bunch of bugs or maybe even like break my entire project. But this is the kind of thing where because I'm not very confident in Cursor, I really want to make sure all my changes are saved. All right, we're finally done with Minesweeper. It took about 2.5 minutes in total. Let's take a look. All right, it kind of seems like it worked. New game. Yeah, I'm pretty impressed. Okay, so it kind of nailed the feature. But let's pretend for a second that we actually weren't happy with this. And I don't know if this has happened to you guys, but if you've told Cursor or Lovable or any of these other tools to make a big change in your app and it doesn't nail it on the first try, it can be really difficult in the conversation to get it back on track. And part of the reason this happens is because when you're in a conversation with it, all of the previous messages are in its context. So it's going to constantly be seeing all of the stuff that it wrote before, and that is going to strongly influence what it's going to write in the future, even if you're telling it what to do and what not to do. Because it could have chosen a bad way to implement things, and it might not figure out that the choice it made at the very beginning was bad. And so it's often more helpful to just start a new conversation and start over. You could start a new chat and start talking with it, but the issue here is Minesweeper already exists. So now you can start the chat and say, hey, like we have Minesweeper and here's all these issues and it might do a little better. But really what we want to do is just start over like this conversation never happened. Maybe we want to save the code, but basically we want to start over like this never happened. Well, luckily with Git, this becomes very easy. I should also point out before we get into the Git version of this, there is a restore checkpoint feature in Cursor. I guarantee you this is using Git under the hood, but we're going to talk about how to do this using Git because this is a more flexible approach that will get you out of a lot more sticky situations. So anyway, let's start a new chat. And once again, we're going to run git status. And not surprisingly, I see a bunch of changes. Again, you don't need to know exactly what all of this means, but you see red, you see any colors here, that means you got changes that are unsaved. So basically, we want to get rid of all of these changes. So Cursor can clean this up for us. It can get us back into the state before it wrote any code. And we can do that by writing a prompt like this. You can say stash all my changes, including untracked files. I want git status to be clean. And by the way, the reason we need to say untracked files, or rather files that are brand new, is because those are treated a little differently in Git. And you kind of want to remind Cursor that it needs to take advantage of that. And you need to remind Cursor that it has to handle that edge case. But don't worry about why that is an edge case. Just remember that it is. So, okay, let's see. Git status. Now we're completely empty. And now we are actually able to go and have a brand new conversation. And again, you could just use the restore checkpoint feature, but I think it's good to understand how that works a little bit under the hood. Now, let's say we wanted to go back in time now. Let's say we actually wanted to completely remove this change. So we don't want Minesweeper anymore. We're not having fun with it. Well, you could go into Cursor and you could say, remove Minesweeper. Remove Minesweeper, I don't like it. And it would go and figure out how to delete Minesweeper from your app. And maybe in this case, it would be able to undo everything it did because it only touched a few files and it's not that complicated. But if you have a repository with hundreds of files and you have a single change that touches 50 of them, if you're just going to tell Cursor to undo that change and you're going to expect it to magically figure out all of the reverse code to write to undo your changes, it's very unlikely to do that. It might get close. It might preserve a lot of the functionality you want, but it's probably going to make some mistakes and it's probably going to leave your repository in an even less useful state. So really what you want to do is use Git to do this. So Git, like I said, makes it very easy to go back and forth between versions. It makes it very easy to go exactly where you want in history. So if we no longer want the Minesweeper change, this is when we want to actually revert that commit. And a reverts in Git is basically undo. So it's kind of like Command Z, but for the entire change set. It will literally undo everything. Doesn't use AI. It's been working for years. And we can just use Cursor to help do that for us if you don't know the commands. So now instead of saying remove Minesweeper, I don't like it, we can say revert the last commit. And it is going to use Git to do this. And we're going to push this up to GitHub and we'll take a look at the changes to see what it's doing. Okay, so it's going to generate the command and then it's going to execute it on the command line for us. Cool. And let's do a git status. And we're going to notice that nothing is popping up. Git status, it's completely clean. And I'm actually glad that Cursor, or Claude rather, is smart enough to know that it needs to check its work and confirm that git status is returning empty. Okay, cool. So now let's go and say, now push it up to GitHub. And it's going to do that for us. And to be honest, guys, for me, I would use the command line exclusively because I'm very comfortable with Git. But if you're just new to this stuff, Cursor can help you out a lot. Do be careful and do try to understand what it's doing. But it's almost inevitable that you're going to get into a bad situation at some point. So just embrace it. All right, now let's go to GitHub. Let's refresh this. And now we'll notice that this page is no longer found. That's actually a good thing. Okay, let's go over here. Okay, now we're looking at the revert change. And if we look here, it's removing the tic-tac-toe that it added before. And so that's two things. One, it's the page that routes everything. So this is the link to the tic-tac-toe. And then two is the actual tic-tac-toe itself. And if we'll notice, because it says reverts commit 476E79D, if we click on that commit, it is the exact opposite. So everywhere here you see green, you'll see red in the other one, excuse me. So everywhere here you see green, you'll see red in the revert. I should also point out, we didn't really go back in time. The entire history is still preserved, even that reversion. So that means Git is tracking not just when you add stuff, it's also tracking when you delete stuff, and you can go back to any of those states. So if we actually wanted to revert this revert, that's also possible. And I know it can get a little confusing, especially for simpler projects, but when you're working on a very complicated project, this level of control gives you so much power and just so much confidence that you're not gonna mess anything up. So it really is incredible software. I hope you guys enjoyed the video. If you've ever lost hours of work while vibe coding, if you've ever basically ruined a project because you weren't using version control effectively, because you weren't saving, leave a comment below. I guarantee you're not the only one. I can assure you every single software developer, even the best of the best, have had horrific experiences with this exact same problem, and you are not alone. So leave a comment below. Hope you guys enjoyed the video. And if you're interested in more information about vibe coding, about any and about this no code stuff, feel free to take a look at this video right up here. Thank you.